Hello and welcome back. This is the second in a series of videos showing us how to use basic pneumatic components. The first thing we're going to look at this session builds on what we watched in the last video. So we're starting exactly where we left off with a single 3 two-way acting valve and a spring return cylinder. What we're going to be doing is in this episode is having a look at logic. So we have two types of logic gates available to us. We have OR gates and we also have AND gates. So we're going to have a look at the two and see how they work. To start with, I'm going to add another button to the circuit. Now and again, as we learned in the last episode, these are actually 3 two-way spring return valves with push button actuation. I'm going to add one to my circuit just below the first one. I'm going to take some air from my manifold away. And that is why you wear glasses. Make sure you turn your air supply off before you plug stuff in. I'm going to take air from my manifold and paste it into the first port on the second button. I'm then going to take the air out of the top one and we're going to work with the OR gate first. So I'm going to clip the OR gate on and put one pipe from the first button into the top and one pipe from the second button into the bottom. Then I'm going to place a pipe finally into my cylinder at the end. So now I'll turn on the air, goggles on, nice and safe, and I can push either button to make the cylinder move. 1 or 2. What happens if we swap this out for an AND logic gate? Well, I'll start by turning off the air supply, then I will unplug the OR and plug in the AND. Can we guess what's going to happen when we start the simulation? Turn on the air. Button 1. Nope. Button 2. No. But both buttons together, now the cylinder moves. So that's just a brief introduction to how to use AND and OR logic gates in pneumatic circuits. Now we're going to start to have a little look at pneumatic sequencing. So far all we've done really is push a button and get a cylinder to move forward, but a lot of time in pneumatic problems you get sequences such as A+, B+, B-, A-. So we're going to look at about the most simple sequence we can to start with, which would be A+, B+. So what do I mean by A+? Well, if we take this cylinder to be cylinder A, at the moment it's in the A- position. As it moves forward, it becomes A+ before moving back again to A-. So A-, B- would mean two cylinders. One which we would call A and another which we might call B. So A would go forward first and then B would go forward. So we're starting with exactly the same circuit that we used the first time. We have a single 3 two-way valve which we're going to be using as a push button. This is going to trigger our first cylinder A. Let's get that working first. Okay, goggles on, air supply on. Push the button, it moves forward. Great. We're now going to be using a roller switch. Now the roller switches work in exactly the same way as the push button switches. They are in fact 3 two-way valves, and it's slightly easier to see how they work. They are listed with a 1 and also a 2. We know that 1 is our inlet and 2 is our outlet. And we also have the 3 listed, and we can see very clearly that it is the exhaust valve. There's an exhaust component fitted to this and we can see it, unlike this where it was trapped inside the piece of plastic. So what I'm going to do is we're going to mount this onto the board. I'm mounting it upside down in this case because it's less stress on the button when it's pushed from below. You could mount it this way up as well, but you may end up eventually wearing the component down. Okay, so I've fitted it onto the board. You'll notice that now when A extends, it causes the switch to actuate. This will in turn allow air to flow from 1, our inlet, to 2, our outlet. I'm going to take a longer piece of pipe, turn off the air supply, plug it into our manifold, and then into 1. Now you might be a little bit of a risk here of the pipe getting caught in some of the components. You can kind of manoeuvre these valves a little bit to make sure that doesn't happen. If you're really safety conscious, what we could do is we could pass the pipe through the back of this component and then plug it in here. So that's really all it's doing, is just keeping the pipe out of the way of the moving cylinder. So now A will move forward, trigger the switch. This will in turn allow air to flow through from 1 to 2, and we want it to go into our second cylinder. Put that onto the board. Air from 2 to the second cylinder. Turn the air on. Nothing happens. And then when I press the button, we'll have A plus followed by B plus. Now it'll be quite quick, so here we go. It almost looks like it's happening at the same time, but I promise you it isn't. What I'll do is I'll just slow down the air supply a little bit and try. Here we go. And you should be able to see. Here we go. A triggers B. So A forward, B forward. A forward, B forward. You'll also notice that A starts to come back before B comes back. It's not truly A plus, B plus, A minus, B minus, because A doesn't get the whole way back before B comes back. But it's just sort of a reset. So at the moment this is just A plus, B plus. For the next part of the video, we're going to start looking at directional control valves. So it's important that we can see exactly how they work, hence the close-up. This is a 5 two-way directional control valve. It's called that because it has 5 ports and it exists in 2 ways or states. If it helps you to think of it as a 5-port 2-state valve, then you can do that. But we normally refer to them as 5 two-ways. So we have down here number 1. This is port number 1. It's our input into the system. So port 1 is our input. We then have ports 2 and 4. 2 and 4, even numbers for outputs, 1 for our input. By default, we can have a little look at the diagram, and I'll get that on screen as well. We go from 1 to 2. So if nothing happened, if you had done nothing else to this valve, air would go into 1 and would also come out of 2. But we have this port up here as well, which is known as the 1-4 port. It's called 1-4 because it connects port 1 to port 4. So, by default, air into 1 comes out of 2, and then when we put air into 1-4, it swaps over inside, and then air goes from 1 to 4. So we can use this to change the direction of something or control, for example, a double-acting cylinder. So that's what we're going to do now. The last thing to mention about this valve is that it is a spring return valve. You'll notice that there is a 1-4 on this side, but there is no 1-2 on this side. That's because it's spring return. You should be able to tell that also by looking at the diagram. There should be a little spring on the other side. So we have a pilot 1-4 on one side and a spring on the other. Let's have a look at how it works with a double-acting cylinder. Okay, so here we are. I've put our double-acting cylinder up on the board. As you can see, this one actually has 2 ports on it, unlike the single-acting cylinder we had before. You'll also notice there is no spring inside this cylinder. If I move it forward, it stays out until I push it back. So it's not going to go anywhere without us telling it explicitly where to go. So that's why we're going to be using this directional control valve. So I'm going to place it directly below, like this. And we have 2 over this side and 4 over this side. We remember that when we power it with 1, air normally goes from 2. So I'm going to make 2 go to this end of the cylinder, so that it retains back by default. So we go from 2 into there, and slightly different pipe, from 4 into the back. This means if we power it by default, remember, it's going to stay exactly where it is. I'm going to take a pipe from 1 to my manifold, making sure my manifold is off. If I was to turn on the system now, nothing will happen, because air is currently flowing into 1 and then from 2 into this end of the cylinder, pushing it back to its current position. So let's just turn this off again. In order to make 1-4 activate, we're going to be using the same 3 two-way valves that we were using before. So, air from our manifold into port 1, and then from port 2 into 1-4. Now, it might be getting a little bit confusing here, so again, I'm just going to tidy up and I'm going to pass wire 1 up through the back of this cylinder and out of the way, so that I can more easily get to my push button here without stuff in the way. If I turn on the air supply, nothing happens, and now when I push the button, the cylinder extends. When I let go of the button, the cylinder comes back. So, out and in. This may seem like a lot of steps to try and get to where we were before with the single acting, but this is really how you should control any cylinder, including single acting cylinders. Normally, all cylinders should be fitted with directional control valves. Okay, so in this example, what we're going to be doing is building on what we had before. You'll remember that we push the button, causing the cylinder to go out, we let go, and it comes back. That was because we were using a 5 two-way valve with a spring return. In this example, we're going to swap that valve out for almost the same thing. Do you remember how in the previous example we had 1-4 that allowed us to connect 1 to 4? Well, this valve also has a pilot on the other side, 1-2, allowing us to connect 1 to 2. What that means is it will flop between the two states, but it will never spring back. This can pose a problem because it means we do not know currently what the state of this valve is. It will be in the state of whoever left it last. So, 1 could be connected to 2, but it could also be connected to 4. All we need to do though is plug it into our circuit to work out which way it was previously configured, and it should sort itself out. So, let's turn off our air supply and then unplug the pipes and put in our new valve. So, air supply goes to 1 at the bottom, then we want to go from 4 to the back, 2 to the front, and just as before, this is going to go to 1-4. I'm going to turn on the air now and see what happens. Okay, the piston's moved out, but I haven't pushed the button. This means that currently the valve is in the 1-4 position. So we're going to need to kind of push it back in order to get this to the function that we want, because at the moment if I press this button, nothing happens. We're going to need a second button, which again is a 3 two-way valve, and we're going to put that just over here for the moment. I'm going to take 2 pipes, one from my manifold, remember to turn the air off, into 1, and 1 from 2 into 1-2. So now we have 2 buttons, one that will make it go out and one that will make it go back. We turn on the air. Top one doesn't do anything yet, but the bottom one will retract it, and now the top one will send it out. So we have 2 buttons, one for forward, one for back. You can't do that without a directional control. One forward, one back. So what if we wanted to take this one step further? Well, we could try and get to a stage where we have an oscillating cylinder. How would that work? Well, at the moment, the cylinder is back, so you would push the button to make it go forward. When it goes forward, it would hit a button which would make it come back, like this. So what we need to do is we need to swap out these 2 buttons for roller switches. Let's have a look at how we would do that. Okay, close-up time again. So, in this next video, I'm going to need to cut some pipe, so I thought I'd use it as an opportunity to show you nice and close how to do it safe. Normally, when you have pipe, it comes in a big reel, like this. This is standard 4mm pipe supplied by Festo. As you can see, the 4mm refers to the exterior dimension, not the interior dimension. So it is the exterior of this pipe is 4mm across. You would think you could just cut it with some scissors or something like that, but the problem that's going to leave is it's going to leave like a really blurred end, and that's going to cause all sorts of problems when you're constantly pushing it in and out of the inlet valves. So we need to use something like this, a pipe cutter. A pipe cutter is a very sharp blade with kind of a guiding channel on how to cut the pipe. all you do is you take the pipe, place it into the channel, as so. There we go. Focus. And then you simply press down. And what you end up with is a really, really nice, clean cut. So, that's what we're going to be doing in the next section. Okay, so I've attached the two roller switches to the board. This one is okay because, as you can see, the cylinder comes back and presses into it. This one will work, but really it should be the other way up. I'm leaving it down here for the moment just because it's going to make the circuit a lot easier for us to see. But if you are building this circuit yourself, please put this upside down to avoid wear and tear. I'm going to start by checking the air is off and running a pipe from the manifold to port 1 on one of my roller switches. Now I could run a second pipe from the manifold to port 1 on the second roller switch, but that would be a lot of pipe, and it's a good opportunity for us to use a pipe splitter. So all I'm going to do is plug this pipe into a kind of T-junction splitter piece. I'm going to take a small piece of pipe, cut it in half, so I have two pieces of pipe, and then I'm going to take one from one of them and one from the other one, and we can plug this in like so. Now you can do this with anywhere where inputs are going into your system. So this is a 1 and a 1. Remember, it's just air going into the valves, so it's okay, we can split it like this. We couldn't connect the two outputs of the valve because that wouldn't make sense. You'd be putting outputs into outputs, but we can do it for our inputs in this case. So now these valves both have power, what I'm going to do is I'm going to take two more pipes and run one from 2 into 1, 4. This will mean if it's back, air will come into 1, 4, 1, 4 will connect, 4 will connect, and this will go forward. It will then actuate this valve. Air will come out of 2, connect to 1, 2 on our 5 three-way valve, and now air will go from 1 to 2, causing this to come back again. So what we should end up with, if I plumbed it in right, is an oscillating cylinder. Hopefully it won't go too fast because I've turned the pressure all the way down. Let's see what happens. Goggles on, air on. Perfect! So I thought it would make sense to have a little look at trying to do a real-world example. So a problem that you might be set would be A plus, B plus, A minus, B minus. So that would be cylinder A at the top here, going forward first, A plus, followed by cylinder B, B plus, followed by cylinder A, followed by cylinder B. So that's what we're going to have a look at now. How would we approach this problem and how would we do the wiring for it? The first thing I like to do is to put all of the components onto the board so that we have them, no plumbing yet, just the components. I've fitted cylinder A and cylinder B, and I've fitted directional control valves. In this case, the same ones we were using in the previous example, 5-port two-way valves, one on each. I've also fitted roller switches to my cylinders, so one for each position that it is possible for them to be in. So the sequence we have is A plus, B plus, A minus, B minus. So you would think that the first thing you would do is try and get the first bit to work, the A plus, but in reality it's often better to kind of work second. But we'll come to that in a bit. What we're going to do first is simply plumb up the air supplied to the components that need it, so just the port 1s. So that's to our roller switches as well as our ports. I've used T-junctions to create things to help me out with this. So I'm going to take air from my manifold and plug it into my switches, into ports 1. So that's the top 2 done. And we'll do the same with the bottom 2. 1 and 1. And again, run it up to my manifold. I could run it through the cylinder if I wanted to get it out of the way of it, but I think in this case it will be easier to just push the ports down a little bit and direct it up to the manifold. So that's my switches taken care of. Next, let's do our valves. We're going to need to use from 1 up to the manifold, and possibly one more as well. Shorter one might do. It's always good to try and use the shortest pipes you possibly can to avoid just kind of cluttering the board up. So let's go from 1 to here. There we go. So now our valves have power and also our switches. Let's wire up these cylinders to the valves next. So this is normally pretty easy. You just need little pipes, and I'm going to stick with what I had last time. I'm going to use 2 as my retract and 4 as my extend. So let's just wire both of those up. 2 retract, 4 extend. So now we get to the bit where we're going to do the logic. And earlier I was saying you would think you would start with the A+. You would think the first thing to do would get that to work. But really I like to approach that last. So the second step, A has already gone plus, now B needs to go plus. So we can see that it is this switch up here, this roller switch, that is going to need to trigger B to go forward, because A moves forward, now B has, and the last action we have is that this roller switch gets triggered. So let's wire this roller switch to 1/4 on this valve, which would cause this cylinder to go forward. No way of really getting around this, we're going to need a long pipe. So from 2 on the roller switch, I'm going to pass it behind the cylinder, just for ease, and into 1/4. So now, this will roll forward, hit this switch, that will cause this to extend. What's the next action? Well, we have A+, B+, A-. So what we need to do is use this switch to trigger this to come back. Okay, so let's take another longish pipe, probably one of these ones. We're going to go from 2 up to 1/2, because remember we want it to retract 1/2. Again, it might be safer just to run this pipe behind this cylinder just to keep it out of the way. You can already see it's starting to become a little bit messy, but that's just one of the prices you have to pay. So, A will go forward, triggering this. B will go forward, triggering this. This will cause this to come back, so we get to here. And we now need to use this switch to trigger this to come back. So, take a pipe. Probably a slightly shorter one might do. No, I think you'll have to do this one. Here we go. So, 2 from the A- position to 1/2. Again, going to go through the back of the cylinder just to keep it tidy. To 1/2 on this valve. That will cause this to retract. And now the cycle is ready to start again. Well, how do we make it start? We need to activate 1/4 using the last switch and the last action we had, which was this down here. So, my final pipe will run from port 2 up behind the cylinder and into the 1/4 of A. So all of this has worked. We will have A+, B+, A-, B-. Almost. What's gone wrong? Is it air pressure? Not enough air. There we go. So nothing wrong with the circuit, just not enough air. Again, I've turned it down to slow it down. In the next video, what I'll do is show you how we can slow down the cylinders without slowing down the air supply. Okay, close-up time again. In this next bit, we're going to be having a little look at this component, which is a flow restrictor. So what these do is they limit the amount of flow of air into or out of a component depending on which way round they're used. They look like just one component, which is a little kind of plastic pipe through and then a lead screw, so you can screw or unscrew the amount of pressure to go through. But actually they're a little more complex than that. They also have a ball valve inside of them. You should be able to see, if you look at the little arrows on it, that there is a direction through which the flow is restricted. The opposite direction, there is no restriction on flow. So this is not the best way of doing this, but if I was to open this up a bit, I can blow through in this direction, and I can also blow through in the other direction. If I restrict the valve right down, I'm then able to blow through only in one direction. So this way, the way that the arrows go will be restricted. I can't blow through, but I should still be able to blow through the other way. And I can. So it's a one-way flow restrictor. We can use these to fit to the cylinders. That's what we're going to have a little look at now. Okay, so I've zoomed in a bit so this bit is a little bit easier to see. What we've got here is a double acting cylinder, a 5 two-way valve, and then 2 3 two-way control valves with buttons on them. This is the system that we had in one of the previous videos, where we have the top button to go out and the second button to go back again. And what we're going to do is we're going to fit one of those flow restrictors that we just looked at. So you might think, because of the way that the restriction goes, the best way to put it would be on this end of the cylinder. Let's try and do that first. So I've got the arrows pointing towards the cylinder. So we're restricting the air going from 4 into the back of the cylinder. Let's turn off the air supply. Swap that out. Arrows going towards the cylinder. Turn on the air supply. And let's have a look at what happens. When I push this button, now we have a slow cylinder movement. When I push the other button, the air that is inside the cylinder is going to exhaust out of this pipe, back through the flow restrictor, but because the arrows are pointing towards the cylinder, it's just going to go straight through, remember the ball valve inside, so there will be no restriction on the backward speed. So, quick back and slow out. This might look like the perfect solution, but it almost poses a problem in itself. Because we're restricting the speed at which air is going into the cylinder, it means the cylinder is not extending with the full force that it's capable of. Let me show you an example. Don't try doing this yourself, because you might catch your fingers. If I bring the cylinder back, and then start it going forward again, you'll notice that I am able to push it, and it's kind of springy. I can push it forward and back. That's because the pressure inside is not at 6 bar, it's being restricted by this, and there's a lot of room for wiggle. And it means that this can be quite a problem if you're not pushing forward with the full force that's required. So to solve that, what we do is, instead of restricting going into the cylinder, a process that is called starving, we're going to restrict coming out of the cylinder instead. Let's change the circuit over and see how that works. So, air off. I'm going to swap this pipe out and this pipe over. So now the air going into the cylinder is restricted. The air coming out from the cylinder, I'm going to exhaust with the arrows pointing away from the cylinder. So we're restricting the air that is exhausting. There we go. Now, when I turn on the air, and let's push it back, so again, it goes back with full speed. Now, when I press this button, it'll still come forward slowly, but you'll notice that I won't be able to spring it. So, air on, cylinder starts moving forward, and I can kind of stop it in its place, but I can't push it backwards. That's because it's got full force behind it. Maybe I'll speed it up just a little bit. There we go. So, back and forward. And again, you can see I'm not able to spring it in the same way that I was able to spring it before. We have full force now behind the cylinder because we are restricting the output instead. Back and forward with force. Okay, so one final thing for this video. I just wanted to show you a couple of other options that we have for using sensors as pneumatic sensors, or potentially ways of slowing or speeding up our system. So what I have set up here is a button, a 3 two-way valve, and our spring return cylinder, and all I've put between them is this component here, which is a pneumatic timer. It has a little dial that allows us to adjust the amount of time that it's set for, and what it does is as air is put into port 1, it starts to count down time until it gets to the end of the timer, and when it gets to the end of the timer, port 2 is opened and the air goes into the cylinder. So it just works like a bit of a delay. So if I turn on the air to the system, press the button, 1, 2, 3, 4, 5, cylinder goes out. If I let go, the valve immediately resets and we can do it again. 1, 2, 3, 4, 5. So that's a 5-second timer that I've set here. I could set any amount. We could just set it all the way down to just being 1 second if we wanted just a weird 1 second delay. Here we go. 1. Maybe that was 1.5. So the second and final component is this. It's a pressure switch. It has 3 ports on it and an exhaust. So we have a 1 and a 2. This is the air that is going through this switch, because this is just a switch. So the air is going through the switch. And we have 1, 2, again, to connect 1 and 2. And this is where we're going to be monitoring our pressure. So whatever the pressure is going into 1, 2 is what causes the switch to trigger or not. This is currently set to 5 bar, and you do that just by turning the knob. I've set it to 5 bar already. So we can attach it to our system. We can take air from 2 to our piston, and we can provide an air supply from 1 through to our manifold. So remember, by default, air just coming from our manifold, waiting and then going into the cylinder. It's not going to go into the cylinder unless the pressure on 1, 2 reaches the right amount. So I've set up another switch with our air, and what we're going to do is we are going to limit the flow of air using one of the flow restrictors from the previous example. We're going to limit the air coming out of 2, and we're going to pass it into 1, 2, and also just into a gauge, just so that we can monitor the build-up of pressure. We don't need the gauge, but it's there so that we can monitor what's going on. So now when I turn the air on, and I push the button, we should see the pressure slowly building here on the gauge, and when it reaches 5, the cylinder should extend. So slowly going up, and going out. I'll zoom in so you can see a little closer. There we go. So, pressing the button, gauge starts to build up, cylinder goes out. So, I hope you've enjoyed these videos so far. In the next video we'll have a little look at the beginnings of electronics, and then in the video after that we'll have a look at electro-pneumatics.